The building isn't broken, it's actively choosing to trap you. You know that familiar feeling when the elevator completely skips your floor? It feels personal. Subject Vern 7734 is currently trapped in the vertical transport tube, continuing observation of the specimen. But it is not a glitch, it is a highly calculated estimated time to destination. Modern central dispatch algorithms do not simply send the closest available car to your floor. Instead, they constantly calculate the most efficient routing for the entire building's daily traffic flow. So while you angrily mash the button in despair, the system is playing complex chess. It analyzes historical daily data to predict exactly when the morning up-peak rush will happen. Empty cars are preemptively pre-positioned at the lobby before the zombie horde even fully arrives. Finally, a heavy door opens. But the dynamic load weighing sensors have already spoken truth. Hidden load cells located under the cabin floor calculate the total physical mass of passengers. If the car reaches maximum physical capacity, the algorithm automatically bypasses all remaining haul calls. It simply ignores you entirely to save energy and time. A brutal but efficient logic. When you finally get a ride, you are experiencing a masterpiece of modern physical engineering. Notice how you barely ever feel the massive steel box accelerating upwards through the shaft. That is the kinematics of comfort at work, perfectly programmed into modern variable frequency drives. Engineers carefully map out precise acceleration and deceleration curves to prevent any motion sickness issues. Without these tightly controlled jerk rates, your morning coffee would instantly end up on ceilings. Behind the concrete walls, perfectly balanced heavy counterweights do most of the actual lifting work. By offsetting the total weight of the car, the motor only needs to overcome friction. This brilliant mechanical system minimizes the electrical energy required to move thousands of pounds vertically. But moving that much solid mass at high speeds creates a massive aerodynamic pressure problem. This phenomenon is called the piston effect. The car violently compresses air as it moves. If the enclosed shaft lacks proper ventilation, this compressed air creates a literal wind tunnel. The air pressure can become so incredibly intense that it actually prevents doors from closing. Of course, the absolute most crucial engineering lies in the mechanical fail-safes hidden directly above. The Overspeed governor is a completely independent safety system relying entirely on basic centrifugal physics. If the car ever falls too fast, spinning metal weights fly outward and trigger catches. This immediately engages heavy steel wedges that physically lock the car tightly onto guide rails. It requires absolutely no electricity. It is pure, undeniable physics keeping you completely safe inside. So the next time you are stuck waiting down in the lobby for 10 minutes, just remember the massive, hidden symphony of data, aerodynamics, and counterweights working behind the scenes. The building is not intentionally ignoring you. It is just optimizing the entire ecosystem perfectly, even if that simply means you have to stand there and wait a little longer. It is a very small price to pay for a perfectly balanced, mathematically flawless ride. Eventually, the complex algorithms will decide it is finally your turn to ascend to work, or in this particular case, to slowly shuffle back to your cubicle for another day. The vertical transport system has successfully delivered its cargo, always ready for the next cycle. Have you ever been trapped by an elevator that completely ignored your urgent button press? Tell us your absolute most frustrating office transport experience down in the comment section below. And always remember to respect the algorithm, because it definitely knows much better than we.